You can see it from back of the room, right? Okay. Okay, so I believe that you watched the video already, right? And well, of course, I will tell you again. You know the optimization. My voice is okay, right? You feel like it's echo. I see. So let let us turn this off. Okay, now you can hear my voice more clear. Hmm? Yeah, they can hear me through this microphone. The problem is I use my own microphone here. So one of my concern is I'm not sure whether they hear my voice clearly because we have that speaker and also the microphone. Maybe it's echo, but it's okay. We turned that off already. Yeah. Well, please confirm you hear me clearly.
Yes,
Anyone
Ajahn.
in the Zoom?
Yes, Ajahn, we can hear you.
Okay, good. All right. So what is the optimization? What is it different from optimization and solving the system of equations? While we can use optimization to the main purpose is just for decision making, right? When you have to design anything, any process of decision making, you can formulate that problem as a optimization problem. That is what we call the mapping or translate from real world problem to optimization problem, right? When we say optimization problem, this structure, we have minimized. Wow. We have objective function where we're going to minimize it or maximize it. Okay, it depends. If you want to maximize it, you can write max, max, right? Maximize. That means, well, we're going to minimize fx. We call the fx as objective function. And in order to achieve minimum fx or maximum fx, it depends. We find the decision variables. X, we call x. X can be a vector, okay, or matrix. Of course, it can be scalar, okay, but it can be many variables, okay, and we have multiple variables. Of course, we can write it as a vector or matrix. You can say array if you want. And what else? X we call is decision variables, right? And this is the most important part of the optimization problem. You need decision variable. If you don't have decision variable, forget it. Okay, it's not optimization problem. Objective function is also important. You need objective function. If you don't have objective function, it's not optimization problem. Okay, and we have a set of inequalities and equalities. We call it constraint. We have inequality constraint and equality constraints. Okay, you see that is plural. Okay. So it can be many constraint, inequality constraint, also equality constraint. Okay. So from real world problem, we're going to represent the real world problem in a form of optimization problem here. Okay. And you see the connection between, yeah, solving optimization problem and solving system of equations. Okay. See that we have equality constraint here. Okay. So the number of decision variables in this case must be less than the number of equalities constraint here. Okay. Why? Because if the number of decision variable here is equal to the number of equalities, we have 0 degree freedom. Okay. So this problem becomes system of equation, right? So you don't have to solve optimization problem. You solve algebraic equations. Okay. What happens if the number of decision variable is less than the number of constraint here? I mean equality constraint. When we say the number of decision variable, well, these decision variables must be independent, right? They are all independent. If the number of decision variables here is less than the number of equalities, well, you have a big problem because we don't have enough degree freedom, right? Degree freedom is less than 0. Okay. We call the system is overdefined. Okay. Okay. So we pay attention to the case where the number of decision variables is less than the number, it's greater than the number of equalities. Okay. And that is a normal case of optimization problems. There are several ways to formulate the objective function, right? The process for decision making is from real world problem, we're going to represent or mapping the real world problem to optimization problem, or we call it mathematical programming. It's the same things. Okay. And once we map or represent it in the optimization problem form, then we solve the problem. Okay. And obtain the solution, right? And we're going to test the obtained solution again to the real world problem. Okay. If not, well, you have to maybe reformulate it. Okay. Or whatever in order to obtain the solution. And, real world problem, when you represent the real world problem by mathematical problem, we cannot 100% accurately represent it. Okay. Always, well, there must be some deviation, okay, from the real world situation. Because in real world problem, of course, you see that it's look like linear function, but maybe it's not linear, right? But it's easier if you represent it as a linear function, something like that. Okay. If you represent it as a nonlinear function, it's maybe too difficult to solve. So it's kind of trade-off between precision and efficiency. Okay. So the objective function can be Of course, our intention is we try to formulate the problem in an efficient way to solve. It depends on available solver, right? What do we have? And the most convenient choice, most of the time, we use linear, okay? And the objective function can be maximize profit, minimize cost, maximize utility, maximize turnover, and so on, okay? What about the constraint? The constraint can be capacity constraint, okay? Raw material availability, marketing demand limitation, material balance, which pose the equality constraints always, okay? Or quality stipulations. Yeah, I explained that already in the video. Okay, so today we're going to implement these things in a very simple example. Okay, in the first example, a company, well, a company manufactures 4 products. Okay, let's say product 1, 2, 3, 4, and in order to produce these products, we need 2 types of machine. Okay, machine 1 and machine 2, and of course, for different products, it requires different amount of hour from machine 1 and machine 2. Okay. Also, each product needs skilled labor and unskilled labor. Okay. And the requirement for each product are different. Okay. For example, in order to produce product 1, we need 11 hours of machine 1, 4 hours of machine 2, 8 hours of skilled labor, 7 hours of unskilled labor. Okay. And the price, the sale price of the product 1 is 300. Okay. For product 2, 3, 4, you can look at the table. And in each month, 700 hours are available on machine 1. And for machine 2, well, we have 500 hours available. Okay. And the company can purchase up to 600 hours of skilled labor at $8 per hour. And for unskilled labor, it's up to 650 hours. Okay. And the cost for unskilled labor is $6 per hour. Okay. So the company wants to determine how much of each product it should produce each month and how much labor to purchase in order to maximize its profit. So can you tell me the purpose of the company? What they want? Yes, maximize profit. So if you want to translate this problem into optimization problem, okay, we can start from objective function first. What is the objective function? Maximize of profit. Okay. So we have to write the profit as a function of decision variables. Okay. So we have to define our decision variables. Okay. So we can, well, we can write the decision variables as xi, where I it's the type of product. Okay, so we have xi, well, includes x1 to x4. Okay, and it represents the number of product I. Okay, for example, x1 is the number of product 1 to manufacture. Okay, the next decision variable is the number of hours of skilled labor to purchase in each month. And the next one is YU. YU is the number of hours of unskilled labor to purchase. Okay, so totally we have 6 decision variables. Okay, right? X1, X2, X4, X3, X4, YS, and YU. Okay, and we have to write the objective function as a function of decision variable, this decision variable. Okay, from the table, from the information available in the table in the previous slide, we can write, wow, the profit as 300 x1, right? 200 times of 260 x2 plus 220 x3, 180 x4. Okay, these coefficients are the price of each product. Okay, and these 4 terms are revenue, right? Okay, so it must be subtracted by cost. How much we going to purchase? I mean, skilled labor and unskilled labor. Okay, so you have to subtract by, well, 8 YS, 6 YU. Now we move to the constraint. What do we have? For constraint, the first one, we have capacity of time on machine 1. Each month, only 700 hours are available, right? So in order to reduce x1, x2, x3, x4, how much do we need? 11x1 plus 7x2 plus 6x3 plus 5x4. And these coefficients are from the table, okay? Look at the table, okay? So the number of hours, okay, required to produce x1, x2, x3, x4 must be less than or equal 700, okay? And the time on machine 2. Time on machine 2 is, well, 4x1 plus 6x2 plus 5x3 plus 4x4. Totally must be less than or equal 500, okay? Which is the available time on machine 2. Okay? And the next one, skilled labor, it's x1 plus 5x2 plus 5x3 plus 6x4 must be less than ys, less than or equal ys. Ys is the number of hours of skilled labor we purchase, the company purchase. Okay? And while the available skilled labor is less than or equal 600, we need to post this inequality constraint too. Now we move to unskilled labor. We write the required unskilled labor 7x1 plus 8x2 plus 7x3 plus 4x4. Okay, this amount must be less than or equal yu, okay? And yu must be less than or equal 650, okay? Which is available unskilled labor, okay? That the company can purchase. And the last one, this is really important, okay? It's not trivial, it's really important. It's non-negativity constraint. You know, x1, xi, I mean, yeah, all variables here cannot be negative, can be 0 or positive, okay? So you have to limit the variables. Xi must be greater or equal 0. Ys also greater or equal 0. Yu must be greater or equal 0, okay? So we combine everything. Now, our optimization problem looks like this, okay? We have maximized here objective function. We write the decision variable here, xi, yu, ys, okay? Subject to a list of all constraints. And when you see this type of objective function inequality constraint, you see that they are all linear, right? That means we can solve this problem by using linear programming. Okay. Now, well, open your Excel. We're going to solve it. One thing, you have to install the server add-ins first. Let me check where to install it. I think in file and option. No? Preference. In my case, I have already installed it and I forget where to install it. I also am using Mac. Maybe, yeah, it's different from your case. File. Option.ใช่ครับ add in อ๋อมีอยู่แล้วใช่ไหมโอเคโอเค file in file and option then add-ins. Okay, you check where it's server already installed. Yes, then it's okay. And it appear here in data. Click data. You see server. Where is it? Or you can well type here server. Where is where is it? Hmm? Ah, here you have to install it first. Not yet. Install add-ins. Click. Yeah, that box, and then okay. ได้ไหมครับ But wow, wow. How about people in the Zoom? Can you install it for for Windows system? You wow. Which menu is it? File, right? File, option, and then add-ins, and then you check for solver. Install the solver. Okay. Okay. Now formulate the objective function. Wow. The variables for x1 is b2 in my case. The x2 is c2. Okay. And x3 is d2. Right? And x4 is e2. ys is f2. And yu is g2. Okay. So I write the objective function in B3 cell. So it is 300 times B2 and 260 times this plus 20 plus this plus 180. No, x4, okay? And subtract by, oh, okay, 8 ys plus 6, yep, yu. Okay? See, this. Okay, now we formulate the constraint. the first constraint is 11 of x2, oh no, x1 plus 7 of x2 plus 6 x3 plus 5 of x4. Okay, this one is lesser or equal 700. อืม Okay. For the third constraint here, you see that we have on the right hand side is not constant. Okay, it's ys, which is our variable. We don't like this way of writing. Okay, then so you should move ys to the left hand side. Okay, so it becomes 8x1 plus 5x2 plus 5x3 plus 6x4 minus ys lesser or equal 0. Okay. And for the non-negativity constraint, you don't have to write it in the Excel. This constraint, I mean, x1, xi is greater than 0, ys, yu is greater than or equal 0. You don't have to write it. Okay, just leave it. We have different way of to handle these constraint. Okay, so well, tell me once you finish, once you reach this state, just tell me. Okay. Okay, so finish? Not yet? อืมอะไรนะทำไมเป็น value มีช่องไหนไม่ ใส่ศูนย์ไปให้หมดก่อนใส่ศูนย์ตรงนี้ให้หมดไปทดสอบดูใส่ศูนย์ไปก่อนไม่ใช่ตรงนั้นข้างล่างช่องสีเหลืองครับผิดจริงเดี๋ยวนะลบออกบางส่วนก่อนนะลบทิ้งไปหมดเลย300เดี๋ยวแป๊บนึงนะคูณพิมพ์ใหม่ ไม่รู้เกิดอะไรขึ้นเนี่ยกด enter ทีหนึ่งลองดูดิโอเคนั่นแสดงว่าได้ละเดี๋ยวแก้ใหม่ให้ครบทุกตัวกันอาจจะเครื่องหมาย เป็นไงบ้างได้ไหมโอเคนะซบแล้วนี่ครับ Okay. So if you finish it, I don't know where your solver, but for me it's under menu of tools in solver. But in your case maybe somewhere else. Okay. Once you select the solver, you will see this window. Okay. And for set objective, you select the objective function cell. Okay. Which is B3? Yes. Okay. And we're going to maximize it by changing variable cell. Click that and I select from B2 to G2. Okay. Now we move to the constraint. For constraint, subject to constraint, add. And on the left-hand side, you see that all the constraint we have here, it's in the same sign, right? Lesser or equal. Then we can select multiple cell like this and select lesser or equal. And on the right-hand side, it's, 2D10. And okay. Okay. So in my case, I combine all these 6 constraints into just only one line. And previously, I told you that we will handle the non-negativity, okay, by using solver itself. So it's important to mark here, make unconstrained variables non-negative, okay, by clicking, by selecting this option, make unconstrained variables non-negative, okay, we limit the decision variables to be positive, okay, 0 or positive. Okay. And for solver, okay, because our problem is linear, so we select simplex LP. LP is standing for linear programming. Okay, we select simplex LP. Then we solve. Okay. No. Nope. No, it's oh, there's some problem in my system. Cannot use simplex LP. No, it's not GRG. It must be hmm? ก่อนหน้าได้แต่ปัญหาคือจะเลือก simplex แต่ว่าพอโซลจริงมันไม่ยอมใช้ simplex ให้ไม่ใช้ GRG ให้ โอเค Okay, finally I got the solution. I know it's linear solver because previously you see that no reports here. If you select a GRG nonlinear, you will not get a sensitivity report. Okay. Okay, so to see the report, you have to select these reports, available reports. Okay, and then okay, click OK. Okay, so well, later we will discuss about the report. We wait for our friends. Okay, first. ได้ Okay ครับ เขียนน่าจะ formulate อะไรผิดนี่นะดูอันนี้ก่อนก็ได้เดี๋ยวแป๊บนึงปิดนี่กันดูอันนี้ก่อนดูทีละช่องแล้ว objective function ก่อน300โอเคไปที่ constraint ฮะ constraint ตัวแรก น่าจะถูกใช่ไหมนี่ลงมาข้างล่างอย่างนี้ถูกไหมเห็นนะครับเล่นถัดไปฮะปุ๊บแล้วอันนี้คืออะไร y ไม่แล้วตรงนี้เป็น yu ปะไม่ใช่ ใช่ ใช่ ไม่งั้นก็ต้องย้าย ys ไปทางฝั่งนี้ การย้าย ys ฝั่งนี้ก็ต้องไปที่นี่ แล้วก็ลบไหนเอ๊ะไหนวะลบys คลิกโอเค enter นะโอเคถูกไหมเพราะมันไม่ใช่เท่ากับศูนย์นะใช่ enter โอเคแล้วก็ over เลือกเดี๋ยวนะ b 3ถูกแล้วใช่ไหมโอเคครับแล้วก็อันนี้ถูกแล้ว b 2ถึง g 2โอเคแล้วอันนี้ b 5 b 10 d แล้วก็ d 5ถึง d 10โอเคน้อยกว่าเท่ากับต้องเลือกเป็นอันนี้ครับ simplex lp โอเคแล้วก็กด solve โอเคครับฮะไม่เข้าใจไม่อันนี้มัน oh no it's no you have to write this again yeah 300 something right 300 times yeah because wow the solver will not change your formula okay here you see that even no not 300 something the constraint is this one should be 11 times b2 plus 7 times other thing right once you solve it the solver just put the value of this variable here okay it will not change your formula at all you see that the objective function still the same 300 v2 and other things okay man
Jan, can you perform this again, please, one more time?
perform what
This objective function solver.
the solver okay
Yes.
you well open the solver
Yeah, we already opened, but can you please do
yeah
it again so that we
open the
can?
solver and then set objective okay you see what I set it right set objective your objective is b3 right so it's b3 cell and you see that what else
Okay, we set the objective then by changing variables.
by changing variables yes.
Yes.
Yeah it's b2 to g2 right
Okay.
and what else the
After,
constraint
yeah, constraint.
the constraint is well it's b5 to b10 okay and on the right hand side of the constraint is d5 to d10 okay
5 to b10. Okay. And are there any cell reference? Should we add any or no?
Cell reference what?
Yeah, cell reference.
I don't get your question.
Uh, should we like add cell reference or no need for that?
No, we add all the constraint. No need for reference.
Okay, okay.
You can add each constraint line by line. It's okay. Yeah, but in this case, because all the constraints are written as a smaller or equal. Okay, so I combine all constraints together in one line. It's
Okay.
okay. You can write this way.
Yes.
And then while make unconstrained variables non-negative. Okay, and select the simplex LP. Okay, and one more thing. Wow, when you now look at the result we obtain, you see that x1 is 16 something, right? 16.66. Well, x2 is 50 and x4 is 33.33. Okay, and y is, if we want to a solution with integer, okay, if you want x1 to be integer and also all xi must be integer and also ys yu is you for it to be integer, you have to add more constraint on that. You can try like adding, and this all constraint must be integer. Okay, okay, this just select the cell of decision variables, okay, and make it integer. And once you solve it, you see that the obtained solution now, well, are integer. Okay. Yeah. But I don't like that one because that one cannot, well, solved by linear programming. It's a mixed integer linear programming. But mixed integer linear programming is available, yeah, in Excel too. Okay. Any questions? The next thing is I'm going to explain about sensitivity reports and answer report. If you solve it with integer constraint, move it back to remove that constraint. Okay. We allow the real number and then solve it again. And select the report, all available report, answer report, sensitivity report, and limits report. Okay. Then you will get all these kind of reports. What do we have here? Now look at the answer reports first. For answer reports, the objective cells is here, B3, right? Previously, we put the objective function in B3 cell. Okay, it's okay, B3. And the final value is, yeah, this value. Okay. And what about original value? Original value is 0. Yeah, in my case, because I start from 0, right? I start from, yeah, all these variables are 0. Then, well, the objective function at the beginning, it's 0. It was 0, and then after optimize it, well, we obtain this value. Okay. What else? Now move to variable cell. Variable cells are our decent variables. Okay. We put decent variable in this cell. Okay. B2 to G2. Okay. And the original value, yeah, previously I set those things 0. Set those things 0. And the solution I obtained are listed here. Okay. And last column of this table, it's integer or not? No, it's continuous. Okay. This means continuous, not integer. All right. And the last table, constraint. Okay, so we have binding, non-binding, binding. Okay. What does it mean? Totally, we have 6 constraints, right? This is the first constraint. B5 less than or equal D5. Okay. Right? Check it. Yeah, this is the first constraint. B5 lesser or equal D5. Okay. And the status is binding. What does it mean? It means, well, this inequality constraint becomes equality constraint at this point. Okay, so it's called binding. Okay, this constraint is binding. Later you will hear about the other word, active constraint. It is the same meaning, okay, as active constraint, because this constraint define the optimum value. So it's binding or active, okay? When we say, wow, this constraint is binding, that means that this constraint is active, or this constraint define the solution, okay? Okay, you see that this constraint also binding, this constraint also binding, okay? The left hand side and the right hand side are equal. First constraint, they are both 700. Okay. And the second constraint, they are both 500. Okay, 0. And this one is not binding. That means it's not active. Okay. And the left hand side value is 583.33. Okay. What about the right hand side? The value at the right hand side of this constraint, the fourth constraint, 600. Yeah. Okay. Yeah. So, well, if we combine this cell value and select value, it should be 600. Okay. This one also binding, and this one also binding. Okay. Okay. Now we move to sensitivity reports. For sensitivity reports, the first table related to variable cells. For variable cell, well, this is the final value, which means the solution, right? The optimum value. And this one is interesting. Objective coefficient 300, 260, 220, 180, minus 8, minus 6. Remember it, right? It's coefficient at the objective function. Okay. So, this table tells us whether what happened if the coefficient here change. Okay. Do we have to solve this problem again or not? Well, you can look at the allowable increase and allowable decrease. If this coefficient change in this range, you don't have to solve your problem again. Okay. The solution remains at this final value. Okay. Allowable decrease means, well, this coefficient 300 can decrease down to 229. Okay. Without changing the solution. Okay. Or if the coefficient change, it can change to 328 without changing the solution. Okay, your solution remains at this point. Okay, but of course the objective function value change. Okay, but x1 to x4 and also ys, yu remain the same. So you see that the coefficient here is the price of the product, right? So if you have a situation that your the price of your product change. Okay. Maybe the product one change from 300 to 310. Do we have to solve the problem again? No, we don't have to solve the problem because the solution remains the same. Okay. We should go with the same plan. Produce X1, this value, X2, this value. Don't produce X3, produce X4, this value. Okay. Also, if the price of the product one change, decrease from 300 to 280, let's say, do we have to solve the problem again? No, we don't have to solve the problem. The solution remains the same. Okay. Let's go with the same plan. Now move to the second row. This is the coefficient of X2, the price of X2. If the price change, yes, what happened to the solution? Okay, this is the price of X3, the price of X4. Okay, and here is the cost, right? Labor cost. If the labor cost change, okay, try this one. Okay. Oh, one thing here. This one, this value. This value means infinity. Okay. Because this is a very large number. Okay. Now we move to the constraint. For the constraint, we have, this is final value, right? The left-hand side of the constraint for each constraint. And this is the right-hand side of each constraint. Okay. And you see that the first constraint is binding, right? It's active because the final value, left-hand side and right-hand side, well, are equal. Yeah, also except the fourth one. Okay. And you see allowable increase and allowable decrease again. What does it mean? It means, well, how large we can change the right-hand side of the constraint. Okay. So if the right-hand side of the constraint, the first constraint, what is it? 700 is a time on machine one, right? Available time of machine one. If we, renovate the process, we buy new machine. And the machine one, we have more time of machine one, maybe 710. Allowable increase is 14, right? So that means, even 410, we don't have to solve the problem. Okay. The solution remains the same. However, the solution changed. But what information, the information we can extract from this row is, we know the solution changed. And we don't have to solve the problem again, but we can estimate the change of objective function. Okay. By changing the right-hand one unit of this constraint, we can improve the objective function by 10.5185. Okay, by this value, this shadow price. Okay, again, if you look at shadow price, because all these on these constraint with positive shadow price, you see they are on binding, right? They are on active. So that means if you change all these right hand side of the constraint, we can improve the objective function. Okay, so which constraint is the most sensitive to the cost, to the objective function? Which one? Yes, this one, right? This fifth one, the fifth constraint. Okay, that means if we change the right hand side of the constraint by 1 unit, it changed 13 point something, right? Okay, so if you want to improve your system, I mean, well, your company, you should increase the number of unskilled labor. This one is skilled or unskilled labor? Skilled labor. Yeah, YS and YU, which one first come first? I cannot remember. Yeah, okay. Oh yeah, that. Okay, so and this information, it's important for the bottlenecking. Okay, if you want to improve your process, which one you should invest? Okay, you can check if it's correct. You see that now, right? Right hand side of the constraint is 700, right? Remember, you take note the objective function first, and then you change. You change the value here from 700 to 699, and then you solve the problem again and see the objective function, how it's changed. It changed, wow, the same number as in reduced shadow price. Then you you select the wrong solver. Yes, try again. Mhm. Uh, Back to the, yeah, cancel it and then open this one again. Yeah, because you force those integer, that integer, you remove that one because it's not compatible with, yeah, the sensitivity analysis. Okay, so any questions? Okay, now we move to the next problem. Example of the problem. This type of problem we call it multi-period optimization problem. For multi-period optimization problem, well, the problem consists of several period time. For example, you plan the production for 4 months, for 6 months, something like that. Okay, we have multiple period. And for each period, of course, there are several decision variable related to maybe operating condition or production plan. And there are some decision variable link between each period. Okay, for example, you can produce your products in the first period, and then of course you keep that and later deliver to your customer in the next period, okay, or later time. Yes. Okay, so for this problem, we have KW Oil. KW Oil has a model to forecast future demand for oil. Okay, so they know that in the future their customer require 5,000 liter in the first month, 8,000 liter in the second month, 9,000 liter in the third month, and 6,000 liter in the fourth month. Okay, and at the beginning, KW Oil may purchase heating oil from a regional supplier at the market rate. Okay, and the price are shown in this table. Okay, the first month, the price is 0.75. The second month is 0.72, and the third month 0.92. The fourth month is 0.9. Okay. Okay, and you see that each month the price are different, right? KW Oil can buy maybe buy oil in the first month and then keep in the storage tank and later deliver to their customer in second or third or fourth month, something like that. And KW Oil has a small storage tank on its facility. The tank can hold up to 4,000 liters of oil. And currently, the tank contains 2,000 liters already. Okay. So the company wants to know how much oil it should purchase at the beginning of each of the 4 months. Okay. Such that it satisfies the projected customer demand at the minimum possible total cost. So what do they want? Yes, minimize cost for the whole period, right? So the objective function should be minimize of cost. And we have to write the objective function this way. Our decision variable is P1, P2, P3, P4, okay, which is the amount of oil purchased at the beginning of each month. Okay. And as I previously mentioned that in case of multi-period optimization problem, we need a special variables to handle the amount of oil in the storage tank. Okay. Well, we set Ti as the amount of oil in the tank at the beginning of month I. Okay. Now we move to the constraint. For the constraint, customer demand in the first month. We purchase PY, P1, right? P1. And at the beginning of the first month, we have T1 in the tank. Okay. And this amount equals 5,000 because we're going to deliver oil, 5,000 liter of oil to our customer, right? And the rest, we're going to keep it in the storage tank. Okay. So it should be T2. And for the second month, P2 plus T2, okay? The amount of oil purchased at the beginning of the second month, okay? And the oil in the storage tank at the beginning of the second month, okay? Equal 8,000 plus T3. And P3 plus T3 equals 9,000 plus T4. And for the last month, P4 plus T4 must be greater or equal 6,000. Because we don't care how much do we have, how much of oil do we have in the storage tank after 4th month. Okay. What about tank capacity? For tank capacity, because the capacity of the tank is 4,000, so Ti must be lesser or equal 4,000. And the first month storage, at the beginning, the company has 2,000 liter in the storage tank. Okay, so T1 must be 2,000. Okay. Also, we need non-negativity for Ti and Pi. Okay, so we combine all these things. We have minimized the objective function with decision variables of Ti and Pi. Okay, and subject to all these constraints. Okay, any questions? Yeah, if no, then we will formulate all these things in Excel. Okay, so this problem we're going to minimize. Okay. Okay. อืมอืมแคนเซิลไปกันโอเคเห็นไหมอยู่ที่เรานี้เจเห็นไหมเป็นช่อง C สอง A สอง L สอง M สองโอเค J ที่หนึ่งบวกที่หนึ่งโอเคสอง E สอง A สองบวก O สอง L สองบวก E สองโอเคอันนี้ก็มีอือฮึอืมอืมโอเคเอาเปิดไปหน้าวินโดว์นึงเลย J ถึงหน้าโซมเลย J โอเค Q J ถึง Q เนาะมินิไมซ์อือฮึอินทิเจอร์ต้องเป็นอินทิเจอร์ด้วยเหรอฮะต้องลบอันเก่าออกหมดอะมีอันไหนออกอีกไอ้พวกนี้ของใหม่เลยใช่ไหมอันนี้ของใหม่ด้วยปะต้องลบออกมันจะต้องเอาเฉพาะของอันใหม่นี้อ่าฮะโอเคครับได้ไหมโชว์ได้นะครับอะไรนะหมายถึงอันไหนคอนเทนต์ไหนคอนเทนต์ไหนจะใส่คอนเทนต์ตัวไหนอ๋อไม่ได้อันข้ออันที่เลือกทั้งหมดนะครับเพราะว่าเครื่องหมายมันเหมือนกันใช่แต่ถ้าเครื่องหมายไม่เหมือนกันทำอย่างนั้นไม่ได้ใช่ต้องกรุ๊ปเฉพาะอันที่เหมือนกันฮะเฉพาะตรงนี้แล้วก็เลือกเท่ากับแล้วก็เฉพาะตรงนี้อ่าอันไหนที่ไม่เหมือนกันต้องแยกบรรทัดครับ ได้ไหมได้โอเค okay let us break for 10 minutes
อาจารย์ครับ อาจารย์ครับ
ใช้ต่อ โอเค กลับกันมาใช่ไหมครับ Okay, so well, any questions from this example? If not, we will move to the next example.
Jan,
Okay.
can we see your solver, please? Because I'm getting different values.
Okay. Okay. You can see it, right?
Yeah, your solver, the one you made, solver.
Solver
Yeah,
the same. It's just a linear LP.
yeah, because I'm getting different values.
I don't know, but you check again the formulation. You put the formula you put in the each cell. Okay.
Okay, linear.
And you have to, well, because this problem is minimization, select minimum. Okay.
Okay.
Select min. Mhm.
Yeah, I selected minimum.
Mhm.
Okay, I will check the formulas again later.
Yeah.
Thank you.
Okay. So we move to the next one. It's a assignment problem. For assignment problems, it's, well, imagine that you have jobs. Okay. Wow. Also, you have several jobs and you have people to handle each job. Okay. For example, we have J jobs. Okay. And well, we have to complete these jobs, J jobs. Okay. And the company has I employees in total to handle these J jobs. Okay. And of course, the skill set of each employee is different. So, well, for example, in this table, it shows the hours, the number of hours to complete each job. For example, the first employee, if they, well, if this employee is assigned to do first job, he or she needs 3 hours to complete it. And if this employee is assigned to complete the fourth job, well, this employee requires 7 hours to do that, to complete that job. Okay, because each employee has different skill set. And if we require each employee to handle only one job, and each job is handled by one employee only. Okay, it is clear that the number of J and I must be equal, right? So so what do we want? The company wants to assign jobs to employees with the condition that first, each employee is assigned exactly one job. Okay. And each job is assigned to exactly one employee only. Okay. Okay. So what is our objective function? Yes. Minimize the total amount of time, right, required to complete all jobs. So we can write the objective function this way. Cij, xij. But I have to explain this Cij and xij first. Cij represents this coefficient. It is a number of hour shown in this table. Okay. Cij means the number of hour required for employee I to complete J job. Okay. And our decision variable is a matrix, the X matrix, Xij. And Xij can take only two values, 0 or 1. If employee I do J job, Xij must be 1. Okay. If otherwise, Xij becomes 0. Okay. So the number of hour, total hour is Cij times Xij. And then we sum all of the Cij, Xij. Okay. Because if Xij is 0, then, well, this term becomes 0, right? Okay. So it's a matrix of 4 by 4. Okay. But each element is binary, 0 or 1 only. Okay. Must be binary. And what about the constraint? The constraint is each employer is assigned exactly one job. Okay. So each employer, for example, the first employer, okay, take only one job means, well, in this row, Xij, the summation of X1j when j is from 1 to 4 must be 1 only, right? It can take the value of 1, only one position here. Okay. So the summation, this row summation must be 1. Okay. And for the second person, second employer, the same. If we take summation through this row, it must be 1. Okay. Also, the same apply to this row and this row. Okay. And the next condition, next constraint is each job must be handled by one employer only. Okay. So we take summation from this column. Okay. It must be 1. Okay. Summation by this column must be 1. This column must be 1. Column must be 1. Okay. You don't sum up this value. Xij. Okay. But the dimension of Xij and Cij is equal. Okay. So the optimization problem becomes minimize of summation by row by column of Cij, Xij. Okay. And the decision variable is Xij. Okay. It's 4 by 4 matrix. And it must be binary. Okay. Take only 0 or 1. Subject to, we have 4 conditions for this. for all I, okay, from this I is not integer. It's 1 to 4, okay? 1 to 4 job. No, 1 to 4 employers. Okay? Each employer, we sum all the xij. Okay? It must be 1. Okay? Summation by row. And for each job, we sum the xij by column. Okay? Each column must be 1 also. Okay? And each xij must be binary, 0 or 1 only. Only 0 or 1. Okay? When you formulate this problem in Excel, previously we used integer, right? This time we must use bin. It's standing for binary. Okay? It can be only 0 or 1. Okay, so let me write this down in the Excel. It's 4 by 4, and we have okay. For how many constraints do we have? 8, right? 8 constraints in total. Okay. 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 And don't forget to force all these variables, these variables to binary.
John, can you show how we
Yes.
get the last four constraints?
Last for constraint.
Yeah,
You mean in Excel?
yeah, man. Yeah, this one.
Okay. Yeah. So, wow, the first for constraint is summation
Yeah.
by row.
Oh,
Yeah. The first constraint. Yeah. Let's see the first constraint. The first constraint is summation from B2 to B5. Okay. It's a column, right?
yeah.
Summation by column, and then summation by column, it's C column, and then D column and E column. And yeah, the fifth one, it's a summation from B2 to E2.
It's by row.
By row, right? Yeah. And then you come down by the third row, fourth row, and fifth row. Just that.
Okay, thank you.
same thing. Copy. No, I'm not speaking anything. Yeah. I'm waiting for everyone to complete the, yeah. solving by Excel. Okay. Okay. So any questions? No? You completed, right? Okay. Then we move to the next problem. Okay. So the next problem is knapsack problem. For knapsack problem, well, imagine that you have a bag or container, and of course, your bag has a limited space, right? If you are allowed to take any goods, yes, from department store, of course, you have to select which one you want to take, right? Because the space in your bag is limited. Okay, so you have to consider this constraint. Okay, so this type of problem, while we consider this problem, a company wishes to ship a number of crates from Toronto to Kitchener in a freight container, and there are 6 possible types of crates. Okay, and each type of crate has a given weight in kilogram and particular retail value in dollar. Okay, which is shown in this table. Okay, so you see that for type 1, the weight is 30 kilogram with the value of 60 USD. Okay, so consider this table, information in that table. Besides, we have following constraints. First, you cannot send more than 10 crates of the same type in the container. Okay, if you choose to, well, ship any types of crates. You cannot ship more than 10 types, 10 crates of the same type. Okay. And the second condition is you can only send crates of type 3 if you send at least one crate of type 4. What does it mean? What does it mean? If you choose to ship type 3, you have to ship type 4. Okay? Okay? You cannot ship type 3 without shipping type 4. Okay? And at least one of the following two conditions has to be satisfied. Okay? Either the first one or the second one. A total of at least 4 crates of type 1 and type 2, okay, is selected. Okay? Or a total of at least 4 crates of type 4 or type 6 is selected. Okay? What does it mean? It means that, well, you have two choices. Type 2 and type 1 and type 2, you ship type 1 and type 2, 4 crates of it. Or you ship type 5 and type 6 for 4 crates. Okay? Yeah, you can do both, but at least one of these, yeah, must be satisfied. You can satisfy both. Okay. And the total weight allowed for the freight container is 1,000 kilogram. So your goal is to design how many crates of each type to place in the freight container so that the value of the crates in the container is maximized. What is our objective? Maximize. Maximize what? The value. Okay. The value of all crates we shipped. Okay. And our capacity is only 1,000 kilogram, right? We can carry on that 1,000 kilogram. And at the same time, we have to satisfy these 3 conditions, right? Okay, so we write the objective function this way. 60 of x1, 70 of x2 plus 40 of x3, 70 x4, 20 of x5, and 90 of x6. Okay, we have 6 types, right? We define x1, x2, x3, x4, x5, x6 as number of crates for each type. Okay. And because we're going to handle the constraint, the third constraint, that either a total of at least 4 crates of type 1 and type 2, or a total of at least 4 crates of type 5 and type 6. So we need one logical variable, just y. Y is a logical variable we use to handle the constraint. Okay. Okay, then we're going to write all the constraints down. First, the limit of our capacity, the weight of all crates we ship must be less than or equal 1,000 kilogram. Okay. What else do we have? Xi from x1 to x6 must be lesser or equal 10, right? Because we cannot ship more than 10 crates of the same type. What about this? X3 must be lesser or equal tens of x4. You can ship x3 if x4 is chip. Okay, so you see that if you don't chip x4, x4 becomes 0, right? And it force x3 becomes 0. Okay, if x4 is chip, it can be 1, 2, 3, 4, anything. The smallest one is 1, right? If x4 is 1, it's chipped. That means, well, it can be 1. x3 can be anything from 0 to 10. Yeah? Yes. If x3 is not 0, x4 must be greater than 1. Okay? Greater or equal 1. Okay? So we handle the second constraint by the second condition by this constraint. Okay? This formulation, this expression x3 is lesser or equal 10x4. Okay? And we need 10 here, right? If we don't put 10 here, x3 is lesser or equal x4. It causes problem because, well, the condition is if you chip x4 only 1 crate, actually, well, for the condition, you can chip any amount of crates, right? I mean, less than 10 of x3. Okay, so this condition cannot be handled without 10. This condition cannot handle that condition. Okay, so you need 10 here. Okay, the next line is x1 plus x2 must be greater than 4 times y. Y is a logical variable. It's binary between, it can be 0 or 1. It depends on the condition. For example, if y is 1, what happened? x1 plus x2 must be greater than 4. Okay, which satisfies the first condition. And we don't care about the second condition because y is 1, then this becomes 0. x5 plus x6 greater than or equal 0, which is always true. Okay, and if we don't care about the first condition where x1 plus x2 is greater than or equal 4, y can be 0. If y is 0, then we ignore the first condition because y is 0, then x1 plus x2 is greater than or equal 0, which is always true. And the second one is x5 plus x6 is greater or equal 4, right? Because this becomes 0. Okay, and all xi must be greater or equal 0, and y must be binary. Okay, logical, can be 1 or 0. And remember that xi must be integer only. Okay, it's a number of crates. Okay, so this problem we're going to optimize, maximize, right? Maximize the value. Remember that from x1 to x6, it must be integer. Okay, and for y, it must be binary. Okay. Okay. So, hmm, come on, this should be integer, isn't it? B B2 to G2, it should be integer. Yeah, but it's okay. I don't know why it's not integer. Maximize it. B2 to H2.เป็นไงบ้างอือฮึอือฮึอะไรเอ่ยน่าจะเท่ากันแล้วอ๋อไม่เท่ากันนะ5มันเท่ากันเท่ากัน19หนึ่งอันนี้ไงจริงๆมันต้องเป็น7นะครับเพราะว่ามันต้องเป็น integer ครับไอ้โซฟเวอร์อาจารย์เป็นอะไรไม่รู้มันไม่ handle Okay, so any questions? Well, the solution should be here should be 0, right? I don't know what happened here. It's the x1 must be 10, x2 must be 10, x3 0, x4 is 0, x5 is 0, and x6 is 7, should be, and y is 0. Okay.
Yeah, Ajahn, I got the same.
So, well, all the constraints are, yeah, satisfied. But the objective function I got here, it's not correct because the x6 must be 7. So it's, yeah, change a little bit.
Ajahn, if you change it to 1930, then it's correct.
Yeah, I can do it. Just one moment.
Yeah.
Because we know that already. This x4 should be 0, right? And
Yeah.
then x6 should be 7. Yeah. Right. So it's 1903. Yeah, 30. Okay. Any questions?
Ajahn, is this okay if I get different constraint values?
Different constant value? What do
Yeah.
you mean?
Like for the last one, I got 7.
Yeah, because I write the constraint different way.
Oh, okay.
So you see that from the constraint. I will show you. Just one moment. For me, well, this constraint, you see that x3 less or equal 10 x4. I move 10 the right hand side to the left. So the third constraint, in my case, my constraint is x3 subtract by 10 x4 lesser or equal 0. And the 1, 2, 3, 4, the fourth constraint, it's x1 plus x2 minus 4y is greater than or equal 0. And the last one, x5 plus x6 minus 4 times with 1 minus y is greater or equal 0. Okay.
Okay, Ajahn, thank you.
Okay, so if no questions, we dismiss. Okay, we finish today's class. Okay.
Okay, Ajahn, thank you.
Yeah, I will post the recorded video later.